Alright you guys, here's number 13 on the homework. If you haven't tried it yet, turn this off and go try it on your own and then come back. But I know all of you would have tried this already, right? Okay, let's take a look at it. Um, First thing, read the problem. 30% of wells find adequate water at 100 feet. Once I see the 30%, I'm already thinking some sort of a proportion test. A local man says he can find water by dousing using a fork stick to indicate where the well should be drilled. You check with 80 of his customers and find that 27 have wells less than 100 feet deep. What can you conclude? So here's what we got. We got P. If we let P be the proportion of all wells that find water at a depth of 100 feet. At 100 feet. Okay, so that's P. Then we are, this local man says I can find water. He found 27 out of 80, so that'd be P hat is 27 out of 80. So he's thinking he's probably better than the 30%. Well, 27 out of 80 is 33.75%. So he's thinking he can probably do a little bit better, right? Because he's, the local guy. All right, what can you conclude about his claim? So if I look at this from a hypothesis test perspective, let me write it like this. One proportion z-test, because all of these tests for proportions are z-tests. Then I'm going to write H0, P is 30%. In the alternative hypothesis, I want to test to see, is it greater than 30%? So this is what I assume true. And this is what I want to show true. Show true, if possible. Okay, because he does it for his record so far is 33.75%. So we want to see, is this really higher than 30%? Or I should say greater than 30%. So there would be A. B, we want to check the assumptions / conditions, because sometimes with the conditions we have to assume that they're true. So the conditions for this test is we have to take random samples, or random. Do we have a random sample? Is this a random sample? Well, I don't know that it's necessarily random, but we're going to assume that we have to assume, hence the word assumptions, that 80 is a random set of wells. So he's not drilling or testing all in the same area, for instance. So we assume that. Because if he is testing all in the same area where all the wells are not as deep, then that's going to affect the outcome, of course. Second condition, our sample size, 80, must be less than or equal to 10% of the total number of wells. And that's reasonable to assume, okay, that 80 is less, that there's more than 800 wells. And 3, NP, 80 times 0.30 is greater than 10. And NQ, oops, not 4. NQ is greater than 10, so that's good. So it's okay to proceed. So we're okay to proceed. Okay, perform the mechanics. So we got the hypothesis, the conditions, the mechanics of the test, or we want to figure out what our z-score is. So here's my graph, and you actually don't have to draw this graph if you write all the formulas out, but I'm going to draw the graph so you can see what's going on. So we've got mu sub p hat is 0.3, sigma sub p hat is 0.3 times 0.7 over 80. And we're trying to figure out what's the chance that I randomly pick a well, or an average of 80 wells, and have the average be greater than 33.75. Okay, because that's my sample, right? That was my sample here. So what's the likelihood of that happening? Okay, let's find the z-score. Is 0.3375 minus 0.3 times 0.7 over 80. And then we'll find the p-value. So I'm going to do that on my calculator. Under stat, tests, 1 prop z-test. P0 is 0.3. X is 27. This is my X. This is my N. So 27, N is 80. And we want to know that we want to test to see if it's greater than 30, so greater than P0. And I get z-score of 0.73, and my p-value is 0.232. Okay, so what does this mean? This p-value means this, that if P really is 30%, I have a 23.2% chance of getting, randomly finding over 33.75% of wells. Let me state this. I think I can write this better. I have a 23.2% chance of randomly finding over 33.5% of wells that are 100 feet or less. Let me write that a different way. And this is a great example that there's lots of different ways to think of this. Okay, so if the population percent, or if 30% of the wells find water less than 100 feet, if I take a random sample of 80 wells, there is a 23% chance that I'm going to get more than 33% of them that find water 100 feet or less. So that's pretty much what I said there, I suppose. Okay, so that's let me make this smaller so we can get it all in there. Okay, so that's what the p-value means. So what's my conclusion? My conclusion is since 23.2% is greater than, we'll say 5% is kind of my cutoff for something being extreme. I don't have evidence that dowsing increases the likelihood of finding water less than 100 feet deep. Okay, or that evidence of that P is actually greater than 30. Okay, does that make sense? So we got 4 parts really to write up. We got the hypothesis. Oh, my pen. We've got the conditions. We got the mechanics. And we got my conclusion. This right here is simply saying, defining what does a p-value mean, which of course you need to know. But these are the 4 parts for a hypothesis test right here. Okay, so again, AP world, it's basically a point for each one out of, if this was a 4-point problem. So you got to make sure you're solid on all of that. Okay, there you go.